My dear students, in this video we are going to see the graph of cosecant, secant, cot and its inverse functions. Graph of cosecant function and its cosecant inverse function. Similarly, the graph of secant and secant inverse, cot and cot inverse functions we are going to see in this video. So the first diagram, the graph of y equal to cosecant x. The graph of y equal to cosecant x. The domain of the cosecant x is minus pi by 2 to plus pi by 2 except 0. Minus pi by 2 to plus pi by 2 except 0. That's why 0 is not in the domain. See, the domain of cosecant x is closed interval minus pi by 2 to plus pi by 2 except 0. And the range of the cosecant x is in the real line except minus 1 to 1. Except minus 1 to 1, these 2 points. Except these 2 points in the real line, or except minus 1 comma 1, the interval minus 1 comma 1. This is the range of cosecant x. In the minus 1 to 1, this interval is excluded from the real number line R. That's why the graph is lying above 1 and below minus 1. The interval minus 1 to 1 is not included in the range. Therefore, the graph of this function is below minus 1 and above minus 1 and also except 0 in the domain. So this is the y equal to cosecant cot. This is the line y equal to 1 and this is the line y equal to minus 1. Below this and above this, the point, what is it? It touches the y line at y equal to 1 and y equal to minus 1. Okay? And lying between minus pi by 2 plus pi by 2 except 0. Similarly, its inverse, cosecant inverse function, the domain of the cosecant inverse function is a reciprocal, the reverse of the domain of range of cosecant is become domain of cosecant inverse, or except in the real line except minus in the interval minus 1 to 1. In the real line except minus 1 to 1 is the domain. Okay. Similarly, range is in the range is except the closed interval in the interval closed interval minus pi by 2 plus pi by 2 except 0. So the domain becomes range and the range of cosecant becomes domain for cosecant inverse. So that's why it is right side of x equal to 1 and left side of x equal to minus 1. Okay, this is the curve. Cosecant inverse curve is this. Okay. Similarly, third diagram, graph of secant x. Domain of secant x is in the closed interval 0 to pi except pi by 2. 0 to pi except pi by 2. And the range is in the real line, y equal to real line, in this real line except the interval minus 1 to 1. Minus 1 to 1 should be excluded in the real line, therefore the curve, this is the curve. Secant x curve is minus 1 to, in the this is the curve in the upward direction above minus 1 and this is below minus, above 1, below minus 1, except pi by 2. Since pi by 2 is not in the domain. Similarly, secant inverse, fourth diagram. For this secant inverse, the domain is real line except minus 1 to plus 1, except minus 1 to plus 1. The interval minus 1 to plus 1, except the real line. This interval, it should be excluded and the range is 0 to pi, value pi by 2 should be excluded. In the interval range is in the interval 0 to pi excluding minus pi by, excluding pi by 2. So therefore this is the curve for secant inverse x. Okay? Secant inverse x, right of 1 and left of minus 1. Above pi by 2 and below pi by 2. Y equal to pi by 2. Okay? So this y equal to pi by 2 is asymptotic line. Similarly, for this curve, x equal to pi by 2 is asymptotic line. This is y equal to pi by 2 is asymptotic line. For secant, it is x equal to pi by 2. Sorry. So this is the line x equal to pi by 2. This is asymptotic line. Here y equal to pi by 2. Similarly, this is x 0. Excluding 0 is the range, x equal to 0 is the asymptotic line. So these four diagrams expressing the diagram of graph of secant x, cosecant x, cosecant inversion, and secant x, secant inversion. Using these ideas, we are going to solve some problems. Okay? My dear students, next we are going to discuss the graph of cot x and cot inversions. See, this is the graph of cot x. The domain of cot x is 0 to pi. 0 to pi is the domain, and range is the entire real line, or range along the y-axis, domain along the x-axis. Domain 0 to pi, and range is r. And this is the graph of cot x, y equal to cot x. This is the graph. This is a line at x equal to pi. Similarly, y equal to cot inverse x is the diagram of cot inverse x is the domain of cot inverse x is r, and the range of cot inverse is 0 to pi. Domain along the x-axis, real line. The range along the y-axis 0 to pi. This is the range, and this is the line y equal to pi, and the graph is like this, y equal to cot inverse x. Now, using these ideas, we are going to solve some problems. Okay? My dear students, now we are going to solve some problems in the exercise 4.4. The first problem is find the principal value of the following functions. First one is secant inverse of 2 by root 3. You know, secant 30 is 2 by root 3. Because cos 30 is root 3 by 2. Therefore, the reciprocal of cos 30, that is secant 30, secant pi by 6 is 2 by root 3. Therefore, secant inverse 2 by root 3 is pi by 6. So, the value of secant inverse 2 by root 3 is pi by 6, which is in the interval 0, pi minus pi by 2. The domain. Similarly, cot inverse root 3. See, tan 30 is 1 by root 3. Similarly, cot 60 is 1 by root 3. Cot 30 is root 3. Similarly, tan 60 1 by tan 60 root 3. The reciprocal is cot 30 is root 3. So cot 30 is pi by 6. Therefore, cot inverse of root 3 is pi by 6, which is in the domain 0 to pi. So the value of cot inverse root 3 is 60, pi by 6. 30 degree, pi by 6. Similarly, cosecant inverse of minus root 2 is minus cosecant root 2. Cosecant inverse of minus root is cosecant minus pi by 4. This is minus cosecant pi by 4. So minus pi by 4 is minus 45. Minus 45 is also in the domain minus pi by 2 to plus pi by 2 except in 0. So cosecant inverse of minus root 2 is minus pi by 4. That belongs to the domain minus pi by 2 to pi by 2. So the principal values of these three functions are, this is pi by 6, cot inverse root 3 is also pi by 6, and cosecant inverse minus root 3 is minus pi by 4. That's all. Okay? Now we will see another problem. Second problem in the exercise 4.4. Find the value of tan inverse root 3 minus secant inverse of minus 2. You know, tan 60 is root 3. Therefore, tan pi by 3 is root 3. So tan inverse of root 3 is pi by 3. That is tan 60. So tan inverse root 3 is pi by 3. Similarly, secant inverse of minus 2 is 2 pi by 3. How? Secant 2 pi by 3 is secant of pi minus pi by 3. You can write this 2 pi by 3 as secant of pi minus pi by 3. Secant pi minus pi by 3, 180 minus theta is second quadrant, secant negative. Therefore, minus secant pi by 3. So, secant pi by 3 is secant 60, that is 2, so minus 2. So, secant 2 pi by 3 is minus 2, therefore 2 pi by 3 is secant inverse of minus 2. So, secant inverse of minus 2 is replaced by 2 pi by 3. Subtracting these two, we will get 3, taking LCM, pi minus 2 pi by 3 is minus pi by 3. So the value of this problem is minus pi by 3. That's all about the first subdivision. Next problem, find the value of cot inverse 1 plus sin inverse of minus root 3 by 2 minus secant inverse of minus root 2. Cot 45 is 1 you know. So cot inverse of 1 is 45, that is pi by 4. Secant inverse of minus root 3 by 2. You know secant 60 is root 3 by 2. Secant inverse of minus root 3 by 2 is minus 60. That is minus pi by 3. Secant inverse of minus root 3 by 2 is minus pi by 3. So this is minus 60. That's why because secant sin inverse is lies between minus pi by 2 plus pi by 2. The domain, therefore this is minus pi by 3 in the domain, therefore sin of minus root 3 by 2 is minus 60. That is minus pi by 3. Cot inverse of 1 is pi by 4. Similarly, as in the case of secant inverse of minus root 2, as we derived already secant inverse of minus 2, now secant inverse of minus root 2. So secant 3 pi by 4, that is secant pi minus pi by 4 is 180 minus theta. Secant 180 minus theta is again second quadrant, secant negative, that is secant minus secant pi by 4. Secant pi by 4 is secant 45 is root 2 minus root 2. So secant 3 pi by 4 is minus root 2, therefore 3 pi by 4 is secant inverse of minus root 2. So therefore secant inverse of minus root 2 is replaced by 3 pi by 4, already minus is here, therefore minus 3 pi by 4. Taking 12 as LCM for all these things, 4, 3, 4, 3 4s are 12, 3 pi, minus 4 3s are 12, minus 4, 5, 3 4s are 12 into 3, 3 3s are 9 pi. So minus 9 minus 4 is minus 13, plus 3 is minus 10 pi by 12. Simplification will get minus 5 pi by 6. So the answer for this problem is minus 5 pi by 6. That's all about the problems in the exercise 4.4. So now I stop my video here. You kindly subscribe my channel and see the videos because these videos are very useful for both the CBSE students and state board students, those who are studying in 12th standard. So kindly subscribe the channel and watch the videos, and those are very important for you. Thank you.